Hello everyone, we are continuing the topic of reservoir fluids in module 2. So here we're going to talk about hydrocarbon reservoirs with gas and oil and usually how they look like. So you see there is an anticline, it's called anticline structural map. So if you look at underground, you see that the different types of rocks underground are layered. So you see that this is one layer, for example, this is another layer, this is another layer, another layer. So this single layer that you see, there are liquids in it in terms of salt, water, oil, and gas. This is one single layer, which is called reservoir layer. There is another rock on the top and another one on the top. So you see different layers are shown with different colors. Okay. In a typical reservoir, these oil and gas and fluids are stored in the pores, we call them. Pores are spaces between the rock grains. Underground is not like a pool. That's what you need to know. Whatever oil and gas we have are stored inside the rocks. And those rocks have pores inside them. And you can see that there are different types of fluids inside the reservoir. Some of the reservoirs may be just 100% oil. Some of the reservoirs might be 100% gas. Some of the reservoir might be a mixture of oil and gas. Some reservoirs might have water, oil, and gas together, as you can see, for example, in this one. So how the fluids are distributed inside the reservoir? These reservoirs usually you have the higher the density of the fluid, it's gonna be deeper inside the reservoir. So that's normal. So if you have a bucket and you pour basically oil, water, and everything inside that bucket and then close the door, right, and add gas to it, right? So you have all these three phases there. The higher the density of the fluid, it's gonna be at the bottom, right? So the water will accumulate at the bottom, then you will have oil, then you will have gas, because this is the way their densities are different, right? So you initially have gas at the top, oil, and then salt water, right? So now these are the main components in the oil, right? So the hydrocarbon gas, hydrocarbon liquid, usually it's called crude oil. Sometimes it's crude oil, sometimes it's condensate. Condensate is much lighter liquid. Most of the components are light in the condensate, while the crude oil, the components are heavy. So with the heavy, I mean they are like the alkanes that we talked about them, like C20, C50, and so on and so forth. But condensate are usually C5, C6, C7 in terms of the alkanes that they are inside them. So now when we want to talk about the fluid properties, so this is an structure of the same reservoir, right? And you can see still we have this this is water, right? This is oil, and the gas actually is not here. This is, let's say, in another example, right? There is a wellbore drilled, right? The wellbore is perforated. Perforation is a process that you shoot. It's like there are guns that shoots the bullet underground and creates communication between the wellbore and the reservoir, and then the oil and gas starts to produce from these holes, right? And then we'll talk about that later on. So this is the way it produces, right? Now, if we want to calculate the fluid properties, remember we talked about the pressure temperature diagram. You want to calculate the pressure, right? How do you calculate the pressure? You have to have a reference depth, which we call it datum. Okay, so datum is a depth which is selected as a reference for fluid properties, right? It is completely arbitrary. It doesn't matter where you select it. I could select it here. I could select it here. It doesn't matter. But you have to select a datum, which is basically a reference for your fluid properties. So later on in other courses, you will learn how to use that datum, okay? But the datum, for example, in this example is at 5,750 feet. and the reservoir condition at that point is 3500 psi and 190 degree Fahrenheit, which is very high temperature, right? Now, remember we talked about again the PT diagram. That's a very important diagram, and how the oil from 100% oil, if the pressure drops, right, as you produce, the pressure of the reservoir drops, right, and you go to the two-phase. So what happens when oil travels from underground to the surface? You have a high pressure here, and as the oil comes to the production line here inside the wellbore, its pressure drops, right? So once its pressures drop, what you get at the surface, the amount of liquid that you get at the surface is less than the amount of the liquid that you had at the top. Why? Because some of that oil have evaporated, right, into the vapor phase. So the amount of liquid that you get at the surface is different from the amount of the liquid that you have at the bottom of the reservoir, because of the phase behavior, because of the pressure temperature behavior of your fluid. Okay, so the amount of liquid that we get at the surface, there is a tank at the surface which we call it stock tank. The temperature and pressure of that tank is 60 degree Fahrenheit and 14.7 psi, and the amount of liquid we get there, we call it stock tank liquid. Okay, so again, the oil that you have inside the reservoir, it's at high pressure, high temperature, right? Once it reaches the surface, its pressure drops to 14.7 psi, and that's exactly what happens in the PT diagram. High pressure, let's say this is 3500 initially, right? Pressure drops until it gets to the surface, to the stock tank, and passes through the separators, right? And now you have some amount of liquid which is less than that, because that liquid that you had there, it was 100% liquid. Now it's 50%, let's say, liquid, right? So that 50% have evaporated. So you have less liquid on the surface. And this is very important concept for you to understand. So now, usually the way that they do this is to analyze this PT diagram and understand how this fluid is. There are two ways. One, they take the sample at the bottom, right? And once they take the sample at the bottom, they put it in a containers that keep its pressure and temperature, and bring it to the surface and start to analyze. Another method is to collect the samples at the surface, samples of gas and liquid, and recombine it again, bring it to that pressure and temperature, and start to analyze that fluid. So there are different ways. You will learn them in reservoir fluid course as well. So here is just an introduction. I guess that's it for this video. I'm gonna continue on the next video.